Hello everyone. Today I'm going to show you a little bit of a refresher about how to use a matrix to fit a function to a set of data points. And we've done this in the past with quadratics and with cubics. If you have a quadratic, you need 3 points. For a cubic, you need 4 points. So today we're going to do a cubic. You can see the 4 points here. And we are going to start by pulling out the writing an equation by plugging in the points for x and y in the function here. So I'm going to start by putting 6 in for x, and 6 cubed is 216. So I have 216a plus 36b plus 6c plus d equals the y value, which is 38. We did this earlier in the year. Now we're doing it again. We're going to be doing it with some larger functions as well. Then we go down to the next data point, which is 5. So we do 5 cubed, 125a plus 25b, 5b plus 5c, 5c plus d equals 74. And then we do it with 2, so 2 cubed is 8, 8a plus 4b plus 2c plus d equals 50. And lastly with negative 1 cubed is negative 1, so we have negative 1a plus 1b minus 1c plus d equals 80. And then we turn that into a matrix by pulling out the coefficients. So we have 216, 36, 6, 1, and 38. 125, 25, 5, 1, 74, 8, 4, 2, 1, 50, and negative 1, 1, negative 1, 1, and 80. I will pause right there. You guys should all grab your graphing calculators and put that into your matrix. You remember you have to go second matrix, and then you have to go over to the edit window. And this matrix here is 4 by 5 if you want to be able to fit all the values in there, so make sure you tell it it's 4 by 5. So you should pause the video here so that you can put that in and evaluate it. Okay, so at this point you should have plugged that into the calculator and gotten out a solution matrix, which is has a bunch of 1s and 0s and looks like this. And then the answers are negative 2, 15, negative 19, and 44, giving us a function f of x equals negative 2x cubed plus 15x squared minus 19x plus 44. And that should be somewhat familiar to you. You share with the nth differences property, which says that if your x values go up by an even amount, the f of x values are constant nth differences, where the number of differences you have to do tells you the degree of the function. Now, you can follow these directions here to do it on the calculator. You do have to enter all the data into your list in order to do that. So it's up to you whether you would prefer to do that or to just start subtracting consecutive values and finding the differences between them. And whichever one you like better, you can do. You do need to be careful about the direction here. You need to be consistent and go the same direction each time. So I'm doing the lower number, subtract I'm doing the number that is further down on the list, subtract the one that's above it. So 44 minus 80 is negative 36, 38 minus 44 is negative 6, 50 minus 38 is 12, 68 minus 50 is 18, 80 minus 68 is 12, and so on. Once you get your first difference, then you have to repeat the process. So I will do negative 6 minus negative 36, which is a positive 30. 12 minus negative 6 is 18. 18 minus 12 is 6. 12 minus 18 is negative 6. Negative 6 minus 12 is negative 18. And 36 minus negative 6 is negative 30. So then I have to do my differences again, and I have to keep going until it's constant. Lucky for me, that happens right now. So I did this process 3 times, which means that this is a third degree polynomial. So at this point, there's an exploration that you can do to help you explore the concepts of finding an equation and relating the equation you can find to the synthetic division that we learned about last class. We are going to have a concept quiz on synthetic division next class as well.